Okay, we previously talked about pure substances as one of the classifications of matter, and now we're going to move on to the other classification of matter, which is mixtures. Okay, pause the video if you want to peruse the objectives, but trust me, what we're doing is relevant. Okay, so here is the overreaching idea. Again, matter separated into pure substances and mixtures. Pure substances divided into elements and compounds, and then mixtures divided into homogeneous and heterogeneous mixtures. We're focusing in this lesson on the mixture side, so homogeneous and heterogeneous. Okay, so mixtures. What does that mean in general? It contains two or more pure substances. Remember that word substance defines either element or compound. A mixture has to have more than one substance. So it could be two elements, two compounds, an element, a compound, 50 elements, 7 compounds, and 1 element. Doesn't matter, just a combination. And it can vary in composition and properties. So Kool-Aid and sweet tea can vary in their sweetness. It's not always 100% the same. H2O is always H2O, but you don't always know what you're getting when you get Kool-Aid or sweet tea. All right. So an alloy is a mixture. It's a mixture of metals, and usually it's a solid, although we can have it as a liquid. So often gold is mixed with other elements like copper, silver, and nickel, and to change its properties. So add some strength, change the color, change the density, okay, so to change the properties. So 18 karat gold, what that means is that it's 18 grams of gold in a 24-gram sample of alloy. So I have 24 grams, but only 18 of them are actually gold. So it would actually be 75% gold by mass in 18 karat gold. 24 karat gold is all gold. Okay. What about homogeneous mixtures? What does that mean? So it means the pure substances are distributed uniformly. Okay, so sweet tea, 14 karat gold, gasoline, syrup, air, apple juice. Any two samples from the same mixture will have the same properties. Okay, so I have a sample of apple juice. I take a bit from here, a bit from here, a bit from here, test it. It's all the same property. All right, so just a little closer, you can see homogeneous mixture. When you look at it, okay, that's sugar water. When you look at it, the molecules of sugar and the molecules of water are distributed uniformly. They're distributed evenly. Iced tea, stainless steel, maple syrup, other examples, homogeneous mixtures. It's evenly spread out. Okay, let's move on to heterogeneous mixtures. So the pure substances in a heterogeneous mixture are not evenly distributed. So they're not distributed uniformly. So like sand and water, or soil itself, or soil and water, oil and water, orange juice. Why orange juice? It says shake well on the container. Same with when you get chocolate milk or something. If it says shake well in the container, it's because the parts settle out. That means it's not homogeneous. It has to be heterogeneous. Smog, which is a mixture of water and pollutants. In this case, two samples from the same mixture may not have the same properties. If I get a salad, that's a heterogeneous mixture. Every bite is not identical, even though it was taken from the same salad. Okay, so a close-up you can see for heterogeneous mixture. This is water and silicon dioxide. You can see they're not distributed evenly. The water clustered in one spot, the silicon dioxide in another. So orange juice and tomato juice, those are examples. Remember, they settle out. It says shake well. Chocolate chip cookies, granite, salad, those are examples of heterogeneous mixture. Okay, so again, just to summarize, remember matter divided into pure substances and mixtures, right? Pure substances are divided into elements and compounds. Mixtures are divided into heterogeneous and homogeneous. And you could see, if you look at the questions, the question says, does the matter have variable composition? Yes, okay, then you're talking about a mixture. If you're not, you're talking about pure substances. When we're looking at mixtures, is it uniform throughout? Yes. Okay, homogeneous. If not, heterogeneous. Which of the following is best classified as a homogeneous mixture? Okay, hot tea, right? A mixture. Okay, one special example of a heterogeneous mixture is a colloid. And in a colloid, there are these intermediate insoluble particles. So these small particles, and they might appear as though they're dissolved, but they're not. Okay, and we know the difference between a solution and a mixture. That's a colloid, because you can see in this illustration, a solution does not scatter light, but a colloid will because of those little particles. Examples include milk, mayonnaise, smog, butter, jello, pudding. Again, they may appear to be homogeneous, but they are not, because they have these suspended particles. Another example is a suspension. So we still have insoluble particles, but these are bigger. In fact, a lot of times they're settling out, and it may be opaque or cause light to scatter either well. A lot of them are going to say shake well. So sand and water, muddy water, flour and water, chocolate milk, orange juice, right? A suspension, a heterogeneous mixture. It's still a heterogeneous mixture, just give it a special name. And then another one is Oobleck. It's a non-Newtonian fluid. It's a pressure-dependent mixture. So move slowly, and it acts like a liquid. Hit it quickly and with more force, and it's stiff like a solid. What type of mixture is coffee? Homogeneous. What type of mixture is soil? Heterogeneous. What about smog? Heterogeneous. Air. Homogeneous. It spreads out. Oil and water. Heterogeneous. And in class, we'll be reviewing with a blue kit. I can't wait. And there you go. Here's learning all about mixtures in the classification of matter. And today, I hope you learned something new.